Hello and welcome to my channel. Through my research, I decided I would show you guys this website that I ran across. This is RyanMarcinek.com, and it's called Where Are You? The Moon Can Tell You. Now let's see, he was out on a Sunday day, blah blah blah. I noticed the moon up in the sky just past first quarter, and I was thinking about the angle of the illuminated side and how it related to some of the positions of the Earth and sun in space. I wondered what information we could gather from the way it looked. This led me to this illuminating post. And here's the link, stars.astro.illinois.edu. I realized if you draw a line from the top of the crescent to the bottom of it, just like this little image shows, that line would be perpendicular to the line from the sun to the moon and consequently from the sun to the earth. But why was this line angled, as per the drawing below? For one, I noticed that this imagery line would point south, which instantly became a great navigation tool. Go try for yourself. Most of the time, it will accurately point south. I say most of the time because it's not accurate when the moon is close to the horizon. This is true for the northern hemisphere, but what about the rest of the world? I looked at some photos of the moon taken by photographers in the southern hemisphere and along the equator. And the findings were quite interesting. Both the position in the in the sky and the angle of the moon changed. Right? Hemisphere-specific views. The imagery line from one side of the crescent to the other was pointing north when viewed in the southern hemisphere, and when at the equator, the line was straight. This makes sense since it seems one side points north and the other points south. So the trick for southern observers is that you can use the moon to point north and get your bearings, the same way as I do on the other side of the planet, northern hemisphere. Then this true realization hit me. For an observer standing on the Earth, the apparent angle of the moon's crescent could be used to give a rough estimate of the observer's latitude. All you have to do is make a line through the moon, just like they did here. Same thing. All you have to do is make a line through the moon, perpendicular to the horizon, and a line from one side of the crescent to the other. The angle between these two lines will give you your rough position latitudinally on the Earth. Sorry, this is what he's talking about, the angle of the observer from the North Pole, crescent line, your perpendicular lines. So there you have it. Now you can, not only can you navigate with the moon, you can use it to figure out where you are on the Earth. Astronomically speaking, the assumptions you make that the Earth is round and that the sun is indefinitely far away so that light falls parallel to the Earth and the moon. The Earth is round for sure, but the sun isn't infinitely away, though it's safe to assume that to make it is a safe assumption to make since the sun is so large and distant. It's amazing how an understanding of astronomy and a bit of math can combine to make some pretty cool navigation tools and tell us where we are on the Earth. This is true science, using what you see to make predictions about your world. Now, what I wanted to point out, as he did, now, as you can see the 5 observers on this globe, and then we have 5 views of the moon, and some are in the southern hemisphere, some are one's at the equator, and 2 are at the northern hemisphere. Now, as you can see, the view of the moon is changing based on their position. So, if you're looking at the moon on the left in the southern hemisphere that's lit on the left side, the only way you could see the moon on the right, over there on the right side, where it's lit on the right side, is to travel to each location in one night on a plane, train, automobile. Obviously, you're going to have a plane. So, right? I mean, that's agreed upon. I mean, millions and millions of astronomers and everyone will agree on that fact. The only way the view of the moon right here in this example can change is if you change your location on the Earth. All right, so now what we are saying is happening, and now you saw this information here, this it's all agreed upon. If things are all hunky-dory, where does this go on here? We got 246. Now, remember that crescent line where you could draw across from point to point essentially? This is the northern hemisphere, what is going on. And you'll see there that line would be pointing at 10:11 p.m. and 3 and 4 a.m. in the clock face. Sorry for the trucks. Here it's pretty much vertical, 12 and 6, 12:30, 6:30, 1 and 7, uh, 2 and 8, well, 2 and 8 even more, and then by 7:25 it's still about the same position. But you can see here we're at 10 and 4. Here we're at 2 and 8. Where? Right here. I mean, how does that correlate? So that means for the guy who just took those pictures that I just showed you, that means he just flew from, let's see, it's clockwise. So he just flew from the northern hemisphere to the southern hemisphere, or basically he had to change his position geographically to see the moon face change or moon disk change. Because right here it's geographical. It's not hourly. It's not field rotation. Because field rotation was not anywhere in that. I mean, we aren't using telescopes. We're using naked eye, unaided viewing of the, stills. No tracking of celestial objects to keep it in focus needed. Going out there and taking a picture. All right, so that's another northern hemisphere view of what is going on right now that should not be happening. Here you can see the moon is spinning counterclockwise. Time stamped, let's see, 6:12 to 12:18. So we're looking at 6 hours. Hemisphere specific use. This is the moon taken from the same geographical location. The same as this one, same geographical location. Okay, so I will put a link to this website. Every website is going to talk the exact same way because the moon is not supposed to roll. The moon face, the moon disk is not supposed to change at an hourly rate. How could a navigator point south from the northern hemisphere? We're talking temperate zones, nowhere near the equator. How is he going to point south if the moon's looking like a smile, a Cheshire grin, or a boat? It's not going to point south anymore. That means he's sitting down in the equator, right? Boat, moon, equator. There's North America, there's Mexico. Boat, moon. Hey, speaking of Mexico and boat moons, you remember that kid? He had it right. So does this guy. No field rotation required because we're just viewing with our eyes. We're not doing long-term astrophotography, taking several hours tracking a celestial object. We're taking stills or just viewing with our eyes. So field rotation does not apply. Okay, so I'm sure if you are interested in more information, you can just search lunar phase on the internet, Google or your favorite search engine, and you will find the exact same information. Just take pictures like this. Take a screenshot real quick of these and take them with you when you go look, and you'll see wax and wane left and right sides. It didn't say wax and wane and then the moon rolls up there to where the top, it looks like the top's illuminated outside equatorial regions like temperate zones, North America, Europe, uh, Africa, Southern Africa, you know, Australia, outside of the temperate zone or borderline areas, or even that's, okay. So enjoy this video, folks. I had a good time making it because I don't know why people are trying so hard to keep saying I need a telescope to do this. Well, I don't see anything about a telescope here for observers telling direction and navigation. Do we all carry around telescopes when we navigate? No, we didn't. People navigated like this long before the invention of telescopes. We've been ocean goers, and those ocean goers could get a general navigation based on the moon because it is very constant. And it's not constant anymore. Because how am I going to tell south if the moon is rolling, the moon face, the man on the moon is cartwheeling? All right? Have a good day.